Okay. Can someone reply if you can hear me? Oh, sorry for the late. I could not start at 10 a.m. And talking about this January month, I could not do the class for 24 online proper time, right? Proper time. So there's a problem with that. I understand. It's because I put some additional classes for physical classes and really I got tired. That's the reason. So, anyways, I will cover the classes that I could not do last week and yesterday. January onwards, everything will be conducting in a normal way. So now, like how I cover the paper class now, we know you know that this online paper class is going very effective way. I could not do that last week paper class, target paper 14. That paper discussion is today at 7 p.m. and target paper 13 recording will be uploaded most probably tomorrow. Then when you are writing target paper 15, then I covered the discussion of target paper 14 and remaining recording of target paper 13. Okay. So February onwards, there won't be an issue with the theory class times also. I do the class at the right time. Okay. Now we were doing actually, we were doing Prism, right? We started Prisms. Give me some time. Give me some time. Last day we started Prism. Today I think most probably we will be able to complete Prism. Most probably. Mm. Today February 1st. Today it's February 1st, right? Oh God. Okay. Oh, I thought still we are in January. Okay. Oh God. Tuesday, the Wednesday, 31st yesterday. I could not do classes on 24th January and 31st January. That means yesterday. Yesterday class is conducting right now. So 24th January class will be conducted tomorrow, as I mentioned, 2 p.m. to 6 p.m. Okay. Then 24. And I see that now. I advise now. Most of you join for the theory class. They join for the paper class also. It's your responsibility not to skip the paper writing every week. Every week now. Now I could not give the marks for target paper 13 and 14. Now target 14 almost I finished marking the papers. So I will send the marks and I will upload your answer sheets also before Friday. Before Friday, I can upload your marks and everything. So therefore, every week, what you should do, it's completely all right. Even you don't join for live physical classes, or even you don't join live paper class, that's okay. That's okay means it's not okay, but that's fine. But please write the papers every week because you can't justify that you could not have time to do the paper. Why? Because I gave a deadline because normally when you do a exam, you have to come at the right time. For an example, Thursday 2 to 4 p.m. there will be an exam. But in my case, I have given 124-hour full day. In the 24 hours, you need to allocate you are comfortable 2.5 hours and write in the paper. It's completely all right. You know, you don't know, even you could not answer a single question. Just at least read the paper and just write down something. Put your name and submit. That is very, very important. It's very, very important. It's very, very important. Okay. Right. Now that past paper discussion also starting from this Friday, tomorrow, I will tell you that idea also. I will share in the group a message. Give me some time. Because last 2 weeks I was really busy. That's the problem. I could not do everything properly because of some personal things that I had to do. 17th. Mm. Mm. Can someone tell me when did we do our last class? Can someone reply? Now, last week I think we didn't do the class. When did we do our last class? 24 theory class. When did we do? Can you reply? Can someone reply? Right. Okay, I got it now. Okay, I got it. Uh, right. Last Wednesday morning. Okay, I got it. Right. I will start now. Where did we stop? Now we started Prism. I think we started. Can someone tell me where did we stop? Where did we stop? Now time is 10:45 so far. I will do until 11:45, 12:45, 1:45, 2:40, roughly 2:30. We discussed about then I gave two questions to try, right? I gave two questions to try. Raise your hands. How many of you did those two questions? I think I gave two questions. Question number 41 and no, I gave you to try question number 35 and question number 45. Raise your hands. How many of you did question number 30? Question number 35 and 45 hands. 35 and 45. Question number 35 and question number 45. There was only one student. Okay, fine. That's okay. Now I will discuss those two questions and I'll go to the theory. We'll discuss that question and I'll go to theory. Okay. Question number 35. The refractive index of a prism PQR is 1.52. What is the required angle of incidence? What is the required angle of incidence to exist tangentially at the face PER? At the face PER. Now, this is the prism. Question number 35. Okay, now we'll start properly. Prism. What is the refractive index? Normally, refractive index means understand that is absolute refractive index. That is always absolute refractive index. Then absolute refractive index of this prism 1.52. I say in N2 is 1.52. Surrounding medium we can consider, unless they specially mention, surrounding medium is always air. Surrounding medium always air. In the question, they say that what is the required angle of incidence? That means incidence angle I1. You remember what is I1? Incidence angle to exist tangentially at the face PR. Now, what would happen? I name this point as point P, point Q, point R. When I was explaining about prisms, I taught you there are two surfaces. The light ray which incident at the first surface. The light ray which incident first, that surface we call as first surface. The light ray which emerges, that surface is what we call as second surface. And this is my first surface, PQ is my first surface, PR is my second surface. Second surface. And PQ is my first surface. First. And then I say there's a light ray incident on this, incident at first surface in this way. Then if I draw a normal to the first surface, AR glass interface, if I draw a normal to the first surface, if not PQ, this will be my normal. This will be my normal. Then what would happen? Light ray refracts from the first surface. Light ray enters from AR to the glass, rare to denser, then refracts towards the normal. Refracts towards the normal. Am I correct? Like this. Then question they mentioned to exist tangentially at the face PR. To exit tangentially at the face PR. That means at first surface, light ray refracts to the normal. Then this light ray incident at the second surface, once it incident at the second surface is a normal, this light ray must refract tangentially along the surface. This light ray must refract tangentially along the surface. Then we know that what would be this angle then? This angle is a normal. This is my refracted ray, if not emergent ray. Then this angle must be 90. I'll ask a question. If you know the answer, put the answer in chat box. Now talking about refraction at second surface. This angle is refracted angle is 90. My question is, what should be this angle? What should be this angle? At the second surface, this angle is what we call as incident angle at second surface. This 90 degrees is the refracted angle. My question is, what should be this angle? Definitely critical angle. Definitely this angle must be critical angle. Because I taught you that what is critical refraction? Critical refraction means when light ray enters from denser to rarer. That's the most popular way how we define critical angle. When light ray enters from denser to rarer, when refracted ray moves along the common interface. The second surface is the common interface for glass and air. When light ray enters from denser to rarer, when light refracted ray passes along the common interface, corresponding incident angle is what we call as critical angle. Critical angle C. This C. This angle is C. Then I want to find this angle I1. I want to find this angle I1. This angle I say R1. This angle I say R1. And they should have given one more important, I think one more additional point. They should have given the prism angle of this prism. So therefore, if you have the tooth inside the bracket, write down prism angle of this prism is 60 degrees. They should have given the prism angle. I think there's a mistake. Write down in the tooth. If you have the tooth, prism angle is equal to 60. Now, raise your hands genuinely. How many of you have did this question before I'm explaining? How many of you got the question answer? Got the answer? How many of you got the answer? Raise your hands. Got the answer. Now, raise your hands. How many of you can get the answer? Now, raise your hands. How many of you can get the answer? Start doing. Now, we learned last day when I was explaining prism section, I taught you some important equation to remember. Prism angle always equals R1 plus R2. Okay. Now you do the question. I revise you once again. If there's a prism, I taught you. This is my incident ray, refracted ray, emergent ray. Then I taught you this angle is how we defined I1. This angle is I1. This angle R1, this angle R2, this angle is I2. Then we learned two important equations. Prism angle, capital A. Prism angle, capital A, always equal to R1 plus R2. Prism angle equals R1 plus R2. Next, we learned that prism angle plus deviation, simple D, equals to I1 plus I2. Equals to I1 plus I2. Now, by using these two equations, now these two equations enough, you can easily find now. You know, now talking about this question number 35, R1 is here, R2 equals to C. And then we know that R1 plus R2 equals to A. Then R2 is C, R1 plus C must be equal to prism angle 60. Now you can easily find the critical angle for glass air interface. The problem is, listen to what I'm saying. Now your target is to find I say I1. Your target is to find I1. If you can find the critical angle for glass air interface, C. Now you know how to find the critical angle for glass air interface. You know that. Then you know C value. From this equation, R2 is C, A is 60, you can find R1. Once you found R1, consider refraction at first surface, apply Snell. Refractive index of air is 1, refractive index of glass is 1.52. You can easily find the I1 value when you apply Snell equation. N1 sin I equals into sin R. Raise your hands. How many of you doing this question answer? Doing. Answer. Raise your hands. How many of you doing this question? Okay, do it. I will give 2-3 minutes. Then I'll start explaining. I'll give 2-3 minutes and I'll start explaining. Today, February 1st, ne? God, still I'm thinking today it's still January. I could not prepare any courses. I could not prepare the paper for tomorrow. Day after tomorrow, I'll prepare 15. Okay. Now, this online practicals will be started from February for you. Unit 3 practicals. Now, for physical students, I did the practicals yesterday. Talking about Unit 2, there are 5 practicals. Talking about Unit 3, there are about 16 practicals. Unit 1, there are only 4 practicals. Unit 2, there are 5 practicals. Unit 3, there are 16 practicals. 16 practicals. So we are going to finish Unit 3 also. Now still we are in the optics, but we can finish optics within maximum 2-3 weeks. We can finish optics. So in that case, Now we can start practicals in unit 3. So I did yesterday practical session for theory class physical students. So we did 4 practicals out of 16 practicals in unit 3. So not next week, most probably in February, within first 2 weeks. So we are taking one additional class and we are doing covering practicals through online. But the problem is now, yesterday many students they failed. Now it's like this. Sometimes when we explain something, while you are doing the question, you listen to what I'm saying, right? Now, sometimes when I explain, you feel that you understand everything. But when you do a question by yourself or only, you start to think, even though you understood when I explain, but when you do a question, you won't understand. So the same thing happens in the practical also. Now, when I now generally now online students, we don't have any way to do the make you to do the practicals by yourself. We don't have such option. So therefore, the way is I explain the practical. This is what you want to do. This is how you want to find the image. This is what you want to do. When you get something like this, you want to do in this way, that way. I just explain the concepts in the board and I show you what reading that you want to do, that you want to obtain, how to plot the graph. I can give an understanding and I can explain everything detailed. Then when I do that, you feel, yes, it's easy, right? Yeah, I got it. Yeah, this is how we want to take the image. Now, when the image is exactly here, this is the point where we want to pin the pin. You think that you understand. But when we do the practicals by ourselves, you understand there are lots of things to learn, right? Sometimes, now, for an example, there's a practical in Prism. There are 2 practicals in Prism. Now, you know what is deviation. You know what is deviation, angle of deviation. Okay. And you know what is critical angle. Practical number 17, practical number 18 belongs to Prism practicals. Practical number 17 is about to check the variation of angle of deviation simple D with the incident angle I1. That means you change the incident angle I1 and you are getting corresponding D values experimentally. So I provide, yesterday we did the practical. I provide all the instruments. Then you want to experimentally, you want to find the values. But the problem is the difficult part is now, when I explain the practical, I say, you want to mark the location of the pins when you detect the image starts disappearing. I mean, it's very easy to say like that. Now you want to locate your pin once you see image suddenly disappears. Then, yeah, right, I got it. Then you think you understood, okay, when the image disappears, I want to mark the pin. But the problem is, it's really difficult to find such location when you do the practical experiment. Sometimes you might get 2-3 images. So that exposure, online students won't get because we don't have any options also for you to do that. I hope most of students who join online classes, they might have covered these practicals in your school, but even though Colombo schools also, they don't do practicals perfectly, especially physics practicals. So if you have any suggestions, tell me. Then if it is possible in my side, I say I help you. If not, conceptually we explain. That's how all the they do. All they just explain in the board and they do one to structure say questions and they stop doing the practicals. But I wanted to give something more than how others give. Okay, anyways, okay. Finished doing. Raise your hands. How many of you finished and got the answer? Finished and got the answer. Still doing hands up. Still doing hands up. Still doing. Quickly. Okay. Okay. Now I'll also start doing. First of all, we'll find the critical angle for glass eye interface. First of all, just find the critical angle for glass eye interface. Now we know that. How do we find the critical angle for glass eye interface? Is the glass Refractive index given as 1.52. Refractive index given as 1.52. I say my first medium is N1 is 1.52. Refractive index 1.52. Then this is air. Refractive index of air, I say N2. Always understand first medium refractive index is N1. Second medium refractive index is N2. Now light ray enters from glass to the air. Angle 90. I want to find the critical angle C. Critical angle C. Then you know that critical angle sin C equals. Sin C equals. We know that refractive index of what? Refractive index of rare medium over refractive index of denser medium. If not, if you can't remember a sin C equals refractive index of rare medium over refractive index of denser medium, you consider this case and apply Snell law. Then also you get the answer. Refractive index of rare medium over refractive index of denser medium. This is the equation. Then sin C. Then sin C equals refractive index of rare medium. Rare medium is air. Refractive index of rare medium is 1. 1 refractive index of denser medium. Denser medium is glass. Glass refractive index 1.52. Someone tell me what is the value for C? If you got the answer for C, someone tell me what is the value for C? What is the value for C? One got 41 degrees 7 minutes. 41 degrees 7 minutes. 41 degrees 7 minutes. Okay, I'm going with 41 degree 8 minutes. It's okay if there is a small deviation with the angles. Okay, I'm going with 41 degree 8 minutes. C equals, when you simplify this, C equals 41 degree 7 minutes. Okay, that is C. I found C. Now, when I found C, I can easily find, now I want to find I1, but I can't find I1 suddenly. I know C, I can find R1. Because we know the equation, A equals R1 plus R2. Then what is my R2? My R2 equals C. My R2 is C. My R2 is C. That is how much? 41 degrees 7 minutes. 41 degree 7 minutes. Prism angle A is how much? 60. I can find R1. I can find R1. Then when I find my R1, R1 equals 60 minus 41 degree 7 minutes. 60 degree minus 41 degree 7 minutes. What is the value? Now some students, they can't subtract 41 degrees 7 minutes from 60 degrees. They don't know how to subtract them. Whenever there is minute terms, what we do, we convert this 60 degree into degrees and minutes. That means 59 degree 60 minutes. Am I correct? 6 degree equals 59 degree 60 minutes. 59 degree 60 minutes. We subtract 41 7. 41 7. Then here we are getting how much? Here we are getting 53 minutes. 59 minus 41 means here 8. 18 degree 53 minutes. R1 is 18 degree 53 minutes. R1. And now you can apply Snell law for first surface. When you apply Snell law at the first surface, you will be able to get the answer. Okay. Now Snell law at first surface, that means PQ. Snell law. Snell law at PQ. Surface, different first surface. Okay, N1 sin I equals into sin R. N1 sin I equals into sin R. N1 sin I equals into sin R. Now, you know that we are writing target number 15 this Saturday. please try to write the paper. That is number one. Try to score more in that paper. Okay. Just try to write the paper number one. Try to score more in that paper. That means we have discussed 15 papers. 15 papers. N1. In this case, N1 means AR, sin I. N2 means glass, R1. Okay. N1 is 1. I want to find I1. Yes, I want to find I1. I wanted to find I1. N2 means 1.52. Sin R. R1 I found. R1 is how much? R1 is 18 degree 53 minutes. 18 degrees 53 minutes. Then when you simplify this, what is the answer? When you simplify this, you will obtain around you will obtain 29 degree 26. 29 degree 26 something. I1 will be. If you have any confusion regarding the simplification, please let me know. The answer will be I1 will be 29 degree 26 minutes. 29 degree 26 minutes, I think. 29 degree 26 minutes. Raise your hands. How many of you understood the way I explained this question answer? If you are able to understand this question, raise your hands. If you are able to understand this question, definitely you can understand any questions in the past papers. Okay. How many of you started doing question number 45? Started doing question number 45. Raise your hands. How many of you started doing question 45? 45. Now I'll guide you. Now 45, light ray entering tangentially from one surface. Light ray entering tangentially from one surface of a prism whose prism angle is 60 degree. Whose prism angle is 60 degree is immersed tangentially to the other surface. Find the refractive index of the prism. The problem is once you drew the diagram, then you will be easily, you can get the answer. The problem is the drawing the diagram. So once you do the diagram, you can easily get the answer. So question number 45, it's not difficult. 45, number 1. 45 number 1. Now write out the prism. Light ray entering tangentially from one surface. Light ray entering tangentially from one surface. This is our normal. This is our normal. Then you know that when light ray entering tangentially, incident angle is 90. Incident angle is 90. Then my question is, that means I1 is 90. Because incident angle is I1, I1 is 90. Then someone tell me what should be R1? What should be R1? Corresponding refractive angle should be equal to which angle? What should be R1? R1 must be C. Am I correct? So when the incident angle is critical angle, refracted angle is 90. If not, when the incident angle is 90, critical refracted angle must be critical angle. So whenever you see 90 degree incident angle, definitely refracted angle must be critical angle. Whenever you see incident angle is critical angle, refracted angle must be definitely 90. Opposite. Agree with opposite. Then this is C. Okay. And also they mentioned light ray emerges from the second surface also tangentially. Tangentially. And then we need to find the refractive index of the prism. And then again, talking about refraction of the second surface, again there is a critical refraction. Refracted angle is 90. We can clearly understand refracted angle is 90. In that case, corresponding incident angle must be critical angle. Corresponding, talking about refraction at first surface, incident angle is 90, then corresponding refracted angle must be critical angle C. That means R1 is C, R2 is C. R1 is C, R2 is C. I1 is 90, I2 also 90. The idea. Not difficult. Am I correct? I1 and I2 both are 90. R1 and R2 both are C. Now we need to find the refractive index of the prism. Refractive index of the prism. Do it. Do it. Now consider this case also, consider prism angle as 60. Consider prism angle as 60. This prism angle is 60. Capital A is 60. Consider capital A is 60. Then once you know prism angle is 60, we know what should be the critical angle. Critical angle must be 30. If you found the critical angle is 30, consider one of the surfaces, first or second, apply Snell law. I'm going with this equation. A equals R1 plus R2. A equals R1 plus R2. This equation. I know A is 60. R1 is also C. R2 also C. C plus C, 2C. 2C equals 60. That means C equals 30. C equals 30. Got C. Right. Then I consider first surface. This surface, my first surface. And we'll apply Snell law. Snell law. Snell law at first surface. N1 sin I equals N2 sin R. N1 sin I equals N2 sin R. Now N1, how much? N1 is now surrounding medium because I consider this surface. Therefore, incident ray is the ray tangential to the surface. Incident ray, refracted ray will be this ray. Then first medium is AR, second medium is glass. Refractive index of first medium AR is 1. Incident angle is 90. Incident angle is 90. 90. Incident angle is 90. Angle made by the incident ray with the normal is 90. Sin 90 must be equal to N2. That's what I want to find actually. Actually, I want to find this N2. I say N sin R. Sin R, refracted angle equals to critical angle C30. Then I can easily find sin 90 means 1. Sin 90 means 1. Then simply sin 30 means half. 1 equals N into half. 1 equals N into half. Then we get refractive index of the prism as 2. Refractive index of the prism as 2. N equals 2. N equals 2. N equals 2. So those questions, prism questions are not that much difficult questions. Those are difficult questions. How many of you started doing 45 number 2 answer? 45 number 2 started doing. 45 number 2 started doing. Now in that case, the refracted ray incident perpendicular to the second surface. I told you that. Can you remember the light ray perpendicular to the common interface? We know that light ray perpendicular to the common interface does not deviate. This idea we know. If a ray passing through two mediums perpendicular to the common interface does not deviate, follow the same original path. We know that idea. Now, number 2 says that A light ray entering tangentially from one surface of a prism whose prism angle is 30, is immersed perpendicular to the other surface. Immersed perpendicular to the other surface. Find the refractive index of the prism. Now this case. Now 45 number 2. 45 number 2. 45 number 2. Right. 45 number 2. Is your prism. Okay. Light ray entering tangentially from one surface. Emerges perpendicular to the second surface. This angle is 90. This is a normal. First surface, normal. Then I know incident angle is 90. This angle, refracted angle, must be the critical angle, you know. Refracted angle must be the critical angle, you know that idea. We need to find the refractive index of the prism. Yes. Prism angle is given as 30. This time prism angle is given as 30. Prism angle 30. You want to find the refractive index simply. Refractive index simply. I'll give 2-3 minutes. Start doing that one. Now geometry. O-level geometry is important now. O-level grade 9, 10, 11 geometry is important now. Now I told you that this angle is 90 because this ray perpendicular to the common interface between glass and air. Ray is perpendicular. This angle is 90. It's small diagram, okay? This angle is 90. This angle also 90. This angle, prism angle 30. This angle 90. This angle also 90. Raise your hands. Did you find the critical angle first? Raise your hands. Did anyone find the critical angle? Only think of this triangle. Only think about this right angle triangle. 90, 30, you can find, okay. Right? Some people found the answer. Very good. If this angle is C, this angle must be 90 minus C. This angle must be 90 minus C. Then talking about this right angle triangle, this angle 90 minus C, this angle is 30, this angle 90. I can easily find C. Addition of these two angles must be equal to 90. 90 minus C, this angle plus this angle must be equal to 90. All your geometry. 90 cancel out. You will get your critical angle is exactly 30. Critical angle becomes exactly 30. Critical angle is 30. But we want to find the refractive index of the prism. Now you can apply Snell law for one of the surfaces. Apply Snell law for first surface. Apply Snell law for surface. Apply Snell law for surface. Snell law. Snell law at first surface. At first surface. N1 sin I into sin R. N1 sin I into sin R. N1. N1 refractive index of first medium AR1. Incident angle is 90, sin 90. N2 means refractive index of glass, that is simple N. Sin R means sin C. Refractive angle is C is 30. Again we are ending with sin 90 means 1, sin 30 means half, sin 90 means 1 equals n into sin 30 means half. We are getting our n as 2. Okay. Then basically there were only 2 questions, but there are 3 questions. Raise your hands whatever we learned from these questions and the theory that we learned before. If you understood, raise your hands. Understood, raise your hands. Understood. You guys understood. Okay. Now we can go to next theory section. Today we can finish Prism and we can start lenses. Okay. Okay. Next theory is some important cases. Before talking important cases, I will give 10-minute break. Now time is 11:20. I think you are staying in the session from 10 o'clock. I'm very sorry I could not start. Normally I start the class at the right time. I could not because there was some work. Okay. I'm sorry for that. Take 10-minute break. Come at 11:30. We'll start we'll start the next session. Next theory. Take a break. Come at 11:30. Okay. Take a small break. Right. Okay. Yes, you can directly apply now. Sin C equals refractive index of rare medium over refractive index of denser medium. It's completely all right. You can directly apply it. There is no issue. Okay, now write down. Okay, the important sections are covered. Right. Now, okay, write down a topic, some kind of topic. Write down. Deciding whether there would be a internal reflection. Deciding whether there would be a internal reflection. I taught you this idea before. We discussed what is total internal reflection. Okay, right on the topic. Deciding whether there would be a internal reflection from second surface. Always understand what is second surface. Okay, from second surface. For the light rays entering from first surface. For the light rays entering from first surface. For the light rays entering from first surface. Okay. Now case one. Case one hyphen, write down case one hyphen, when R2 less than C. You know what is R2? You know what is C? Case one, when R2 less than C. Case one, when R2 less than C. Right? Okay, then I do the diagram. Do this diagram with me. Do this prism with me. A normal incident ray, normal, then our refracted ray, normal at the second surface, normal drawn at the second surface. Then you know this is I1, this angle is R1, this angle is R2. I only mark R2 and yeah, I only mark R2. Now you know when R2, this angle is R2. Can you remember when total internal reflection occurs? When light ray enters from denser medium to rarer medium. In order to occur total internal reflection, I taught you that light ray must enter from denser medium to rarer medium. In this example, glass to the air. Then suppose incident angle, that means R2, greater than critical angle, I taught you, then light ray undergoes total internal reflection. Am I correct? Okay, very carefully listen. Talking about R2, when R2 gradually increases from 0 to a larger values. When R2 gradually increases from 0 to larger values, until R2 equals to critical angle. Until R2 equals to critical angle, what would happen for the refracted ray? Refracted ray enters the second medium. R2 gradually increases from 0 to critical angle until R2 reaches critical angle, light ray refracts to the second medium. When R2 exactly equal to critical angle, I taught you, refracted ray passes along the common interface. When you try to increase R2 further beyond the critical angle, I told you, light ray undergoes total internal reflection. Then this time R2 is not yet equal to critical angle. That means R2 is less than critical angle. When R2 less than critical angle, what would happen for the light ray? Light ray refracts to the second medium. Light ray refracts to the second medium. Light ray moves from dense to rarer, refracts away from the normal. Now use different color pen to mark down this ray. Write down. Once you finish drawing, write down. Write down. When the incident angle at second surface, incident angle at second surface. Okay, write down this as second surface. If not, you will confuse. Some people now, incident angle at second surface. This is your second surface always. Second surface, first surface, third surface. Second surface. Okay, this is first surface. Write down a point. When incident angle at second surface, inside the bracket put PR. We'll name this PQR, PQR prism. Inside the bracket PR. Close the bracket. Is less than the critical angle. Is less than the critical angle. Is less than the critical angle. Tamam. Light ray refracts. Light ray refracts to the second medium. Light ray refracts to the second medium from PR surface. From PR surface. Okay. Then, now case number 2. Case 2. When R2 exactly equal to critical angle. Case 2. When R2 exactly equal to critical angle. Case 2. When R2 exactly equal to critical angle. This time R2 exactly equal to critical angle. Then we know in this case what would happen for the refracted ray? Undergoes what? Critical refraction. That means diffracted ray passes along the second surface. Draw the prism again. Now don't be lazy to draw the diagrams. Draw the prism again. Nicely maintain your knots. Because in case if you do second shy for an example, for an idea, in case if you are doing second shy, if you don't have a proper knot, then you want to depend from others. Because even though you are best friend, even though your best friends are bright friends, we can't sure about their knots. Because every day, very rare to find a friend who goes classes daily without skipping a day. So then understand the importance of maintaining a perfect notebook. It is really important, very, very important. Therefore, always maintain a beautiful note. It's your responsibility at this time. Draw the prism. Incident ray. Normal at first surface. Refracted ray. Normal drawn at the second surface. This angle is R2. This angle R2. When your R2 exactly equal to critical angle, then light ray undergoes critical refraction. That means refracted ray passes along the second surface. Okay. This is 90. Quickly. This diagram, okay, we'll mark some, this angle is I1. This angle I1. This angle is R1. Prism angle is capital A. Prism angle capital A. Okay. Then write down a point. Write down a point. When the incident angle at second surface inside the bracket PR. When the incident angle at the second surface inside the bracket PR, close the bracket, is equal to critical angle, is equal to critical angle, comma, the light ray moves along second surface. The light ray moves along second surface inside the bracket PR, close the bracket. Okay, right. Next, okay, next. Now we can, now we know the two equations, A plus B equals I1 plus I2 and A equals R1 plus R2. Now in this case, R2 equals C. Okay, in this case, R2 equals C. Okay, anyways, okay, we'll write on these equations also. Now you know that this time R2 equals C in critical angle. So then I can write down R2 equals to C. These are not standard equations or something, but we'll write this equation to get familiarized with them. R2 equals C. Then we know A plus B equals C. Then yes. Then we know A equals R1 plus R2 equation. A equals R1 plus R2 equation. Now this time R2 equals C. R2 equals C, then we will get that A equals R1 plus C. These are not standard things, but to get a familiarization, just write down these things. R2 equals C, A equals R1 plus R2, R1 plus C. That is one thing. Then, okay. Then what is the deviation? Now, deviation, angle of deviation at first surface, angle of deviation at first surface. I say D1, angle of deviation first surface. This is what we call as angle of deviation at first surface, that is D1. Then D1 equals, now we know D1 equals I1 minus R1. D1 means we know I1 minus R1. I1 minus R1. What can you say about angle of deviation at second surface? Angle of deviation at second surface, D2, we know that D2 equals R2 minus R2 minus, okay. Now R2 minus I2, right? Now angle of deviation. Then talking about the refraction at second surface is the direction of the light ray. Now it is moving like this. Then this angle is R2. Then this angle is I2, R2 minus I2. Then my R2 is 90. I2 means how much? I2 is equal to, sorry, R2 is, yes, R2 is 90. This is I2, my bad, okay. This is my R2, this is my I2. I2 minus R2, my bad, okay. I2 minus R2. I2 is 90. 90 minus C. Angle of deviation at second surface will be 90 minus C. Please highlight that one. 90 minus C. Angle of deviation at second surface, 90 minus C. It's not important. It's not important, but it's okay. Just write down. So once you wrote until there, please raise your hands. So once you wrote until there, raise your hands. There is no, we didn't learn any something new theory from these cases, but whatever we learned up to now, we apply for some cases and we get familiarized with those cases. So once you finish writing until here, raise your hands. Okay. Right. So then Roman number 3, case number 3. Case number 3, when R2 larger than C. Case number 3, when R2 larger than C. Case 1, R2 less than C. Case 2, R2 equals C. Case 3, R2 larger than C. Then we know that when R2 larger than C, it undergoes total internal reflection. And do the diagram again. Case 3. Case 3, R2 larger than C. In that case, if I draw the prism, so then incident ray, refracted ray. Now R2 is greater than critical angle. R2 is greater than critical angle. This angle is R2. This angle is R2. And then what would happen for the ray? Ray undergoes total internal reflection. Without refracting to the second medium, this ray will come back to the same medium. Now light ray undergoes total internal reflection. This angle is also R. Now draw this diagram also. But you need to understand, now listen, this is important. Now, this is the first surface. Second surface, this will be the third surface. First surface, second surface, third surface. Now, when your R2 is larger than critical angle, understand, we know that light ray undergoes total internal reflection from that second surface and light ray enters to third surface. But the problem is depends on the angles. Depends on the angles and refractive index of the mediums. The direction of this reflected ray will be different. For an example, now I have drawn this reflected ray in this direction. But sometimes this reflected ray can be reflected perpendicular to the third surface. In that case, what will happen? In that case, I will draw only this section. I will draw only this section. Very carefully listen. So there are many, I can divide the refraction of reflected ray into further sections. Listen very carefully. Carefully listen. Now, this is my third surface. Second surface. This is your normal. Okay. Suppose if you are reflected ray reflecting in this way, this direction, slanted in this direction, not slanted in this direction. In that case, how would be your ray diagram? Like this. Can be. If not, if your reflected ray is perpendicular to the third surface, then there won't be any refraction from the third surface. If not, if your internally reflected ray will reflect this way, it goes like this. There are many possible parts. So draw this diagram. And separately somewhere else draw this diagram also. Might be useful. It might be useful. Draw those diagrams also. Now, the direction of the path decides by the angle and the material of the mediums. Understand that idea. Okay. Right, okay. Now, I think that section also done. Now, we are talking about very important section. Very important section. Most of your practicals are based on this section, minimum deviation angle. How to find minimum deviation angle. That's important. Now, whatever we learned until now, if you understood, raise your hands. Understood everything. Understood. Hands up. Everything is very clear. Okay. Then put your main topic. Now, this is an important point. Important topic. Main topic. Now, next break will be at 12. Write down the variation of angle of deviation. The variation of angle of deviation. Inside the bracket, total. The variation of total angle of deviation. Write down like this. The variation of total angle of deviation with incident angle. With incident angle. During refraction through the prism. During refraction through the prism. During refraction through the prism. Right. First of all, we'll draw the prism again. We'll draw the prism again first of all. Then I will explain the graph and the theory. I'll draw a prism. I'll draw a somewhat large prism and mark all the angles I1 for a general case. Draw the prism and mark all the incident I1, I2, R1, R2, deviation D1, deviation D2, total deviation D, prism angle capital A. Mark all the possible angles. Mark them. Mark them. Now, I hope that you have a good understanding about what is this deviation angle, angle of deviation. Because I don't explain what is angle of deviation right now, because already explained. Prism angle A. Incident ray. Incident ray. Incident point. Normal. Normal. Refracted ray. Normal drawn at the second surface. Emergent ray for general situation. Initial direction of the incident ray is in this direction. Final direction of the ray is in this direction. Then incident angle I1, R1, R2, I2. Deviation, angle of deviation at the first surface. Initial direction of the ray is in this direction. Now, refracted ray direction is in this direction. Angle of deviation at first surface, this is D1. This is D1. This angle is D1. Talking about angle of deviation on the second surface. Direction of the incident ray in this direction. Now direction of the ray is in this direction. Angle of deviation will be this is D2. Total angle of deviation, initial direction, final direction, simple D. Already explained this idea. Now we are talking about the variation of total deviation, simple D, from both surfaces. We know Deviation occurs from first surface as well as deviation occurs in the second surface. When light ray moving through the prism, deviation occurs. If not, path changes due to the refraction from first surface, and again path changes due to the refraction from the second surface. Okay. Now I want to consider how this total deviation, that means simple d, that means d1 plus d2, how total deviation varies with the incident angle I1. When I increase I1 gradually, what would happen for the deviation, total deviation d? Okay. So once you finish drawing this one, okay, I will explain the graph also. Now this is an experimental result. Now scientists, what have they done? Once they mark some incident angles, and what have they done? Practically, they found the corresponding total deviation angles. Because you are going to do this practical. This is the practical number 17. For different incident angles, I1 values, you are going to find corresponding D values. You are increasing your I1 from 30, 35, 40, 45, 50, 55, 60, 65, 75, 85, 95. Sorry, 85. Yes, 85. You are increasing your incident angle I1 and you are going to find the corresponding total angle of deviation D. Then when you plot the graph, you will obtain a graph like this. This is important. Variation of angle of deviation with the incident angle. Incident angle is I1, incident angle I. Deviation, simple D. Then you notice, when you increase the angle, I keep some kind of blank. I will explain the reasons and everything later. Right? Generally, I start increasing the incident angle. I1 not from the zero. There's a reason. I will explain later. Okay. I start increasing the angle from 30 to 85, 90. When I increase the angle from 30, for example, 25, from 30 to 85, 90, when I increase my incident angle from 30 to 85, when I increase my incident angle, and when I found the values of angle of deviation and when I plot the graph, I am getting a graph very similar to this shape. Then you can clearly understand slope is very higher in this part of the graph. The slope of the graph is very lower in this section of the graph. So what is the meaning? What is the idea? When you look at this graph, what will be the observations that you obtain? Incident angle increases. But intentionally, this person, the person who drew the graph, intentionally, he kept a small gap in the incident angle. He started drawing the graph from a certain incident angle. So I will explain why this person kept some kind of why this person started drawing the graph from a certain incident angle. Rather than increasing the incident angle from 0 to larger values, why this person started measuring incident angles from 30 to something. I will explain later. First of all, we'll understand the shape, the reason behind the shape of the graph. Now, I noticed when I increase the incident angle I1 gradually, 30, 35, 40, 45, 50, 55, 60, 65, 70, likewise increasing, angle of deviation decreases suddenly. Rapidly, angle of deviation decreases. At a certain incident angle I obtain, what would happen? Certain incident angle. My angle of deviation becomes minimum. At a certain incident angle, what would happen? Angle of deviation is minimum. So I mark the minimum angle of deviation as capital D. at a certain incident angle. When I further increase incident angle, again angle of deviation started increasing, but this time slowly. When I increase the incident angle from a certain value to larger values, initially angle of deviation decreases rapidly. At a certain instant, for a certain incident angle of deviation became minimum. When I further increases my incident angle, I obtain angle of deviation increases again, but with a slow rate, slowly. Draw this graph. Draw this graph. Draw this graph. And write down. Write down something. Finish drawing. So once you finish, raise your hands. So once you finish drawing, raise your hands. Then I'll ask a question. Think wisely and reply. Now, by looking at this graph, you need to answer. You obtain other than one case, other than certain instant, other than one certain instant, you can obtain same total angle of deviation for how many incident angles? My question again, other than one certain instant. Okay, there is only one certain instant that is not applicable for the question that I'm asking. Normally, generally, you obtain same total angle of deviation. You obtain same total angle of deviation for how many incident angles? For a certain angle of deviation, you obtain for how many possible incident angles? That is my question. For an example, let's say now total angle of deviation is 50 degrees. You obtain 50-degree total angle of deviation for how many incident angles? When your I1 becomes how many angles? You obtain same total angle of deviation. Any answer? Any answer? There are always two possible incident angles. There are always two possible incident angles I1. You obtain same certain total angle of deviation. Now look here. Other than minimum deviation. Now I consider this angle of deviation as a simple d. Simple d. Now simple d can be a value. It's an angle. Simple d is an angle. I said this d is 50 degrees. Then you obtain angle of deviation simple d. You obtain angle of deviation simple d when your incident angle, when your I1 is for two values. You obtain same angle of deviation for two corresponding incident angles I1. When your incident angle is I1, then also you obtain your angle of deviation as simple d. And when your incident angle is equal to, I say I2, then also you obtain same angle of deviation. And the conclusion is, generally, there are two possible incident angles where you obtain same angle of deviation. Okay, that is one important point. Other than one instant, other than one specific instant, when minimum angle of deviation, there is always possible one incident angle. Okay, in order to obtain the minimum deviation, there is always one possible incident angle. Now raise your hands. Did you understand what I'm saying? Did you understand what I'm saying, hands? If you understood what I explained, raise your hands. If you understood, raise your hands. Okay, the first important condition is talking about angle of deviation, incident angle graph. The observation. So when you look at the graph, what you observe? The observation is when incident angle increases from a certain value, initially angle of deviation decreases, reaches a minimum value. That is what we call as minimum deviation angle, again increases slowly. Talking about angle of deviation decreasing rapidly, angle of deviation again increasing at a slow rate slowly. The next important condition is there are two possible incident angles which provide same total angle of deviation. There is only one and only incident angle which provides minimum deviation. Only one incident angle. Minimum deviation is possible only in one angle. The next important thing, the next confusing important thing. Now, I told you before, there are two possible incident angles which provide same total angle of deviation. In this case, you obtain simple d total angle of deviation when your incident angle, this angle is I10, when your incident angle is I2. This angle is either I1 or I2, you obtain same total angle of deviation d. Okay. Now listen very carefully. It is really confusing. Now, if I explain with the variable, sometimes you will get confused. Therefore, I take some values for I1, I2 and simply I explain. Now, let's say you obtain total angle of deviation 50 degrees. Total angle of deviation 50 degrees for two possible I angles, two possible incident angles. I say one incident angle is 30 and other incident angle is 60. For an example, when your incident angle, this angle, when this angle is 30, total deviation is 50. When this angle is 60, again deviation is 50. Okay, you can understand that idea. Now let's say when your incident angle at first surface, when your incident angle at first surface 30, then deviation is 50. Understand, refracted angle at the second surface will be the 60. I2 will be 60. When your incident angle is 60, when your incident angle is 60, deviation 50, then corresponding refracted angle at second surface, I2 will be 30. Do you understand? Do you understand? Okay. Now, the idea is there are two incident angles which provides the same total angle of deviation. For an example, 30 degrees and 60 degrees are providing total angle of deviation 50. Suppose your incident angle at first surface, that means I1 is 30, definitely your I2 will be other possible incident angle. I2 will be 60. Suppose your I1 is 60, other possible I2 will be 30. Did you understand? Raise your hands. How many of you understood what I explained? Did you understand? This is important. MCQs, this is what they give. We'll do some questions also. Okay, that is the main concept. I hope you understood. Okay, once you finish writing, write down. Okay, we'll write down a point, blue color pen, a point, write down. When incident angle increases from 0, when incident angle increases from 0, comma, the total angle of deviation starts reducing. The total angle of deviation starts reducing. At a higher rate, at a higher rate, at a higher rate. And reaches a minimum deviation angle. Reaches a minimum deviation angle. Please highlight, take your highlight and highlight. Reducing at a higher rate. Highlight reducing at a higher rate. Another different color highlight, reaches minimum deviation. Reaches minimum deviation. Next point, write down. If not, even you continue for the same point, fine. It's up to you. Write down. When angle of incidence further increases, when angle of incidence further increases, comma, then total angle of deviation, starts increasing again with a lower rate. Starts increasing again with a lower rate. Highlight increasing again with a lower rate. The red color pen important write down. Red color pen important write down. Red color pen important write down. Except the minimum deviation case, comma, there are two possible incident angles. There are two possible incident angles. There are two possible incident angles. Inside the bracket I1, okay, to obtain a certain total angle of deviation. To obtain a certain total angle of deviation. Okay. Then next point, red color pen. Next point, red color pen, write down. When one of those incident angles is equal to I1. Now you know what is I1, right? When one of those incident angles is equal to I1, then I2 will be the other possible incident angle. I2 will be the other possible incident angle. I2 will be the other possible incident angle. Next point, red color pen. Next point, red color pen, write down. There is only one certain incident angle. There is only one certain incident angle. Which will provide minimum angle of deviation. Which will provide minimum angle of deviation. All right. Yes. Okay. Then that idea is also done. Now you know what is minimum angle of deviation. Now put your subtopic minimum deviation inside the bracket capital D. Normally simple D we used to represent the angle of deviation. Capital D we used to represent minimum angle of deviation. The minimum deviation, main topic, minimum deviation inside the bracket capital D. Minimum deviation inside the bracket capital D. Write down. Minimum deviation angle is obtained. Minimum deviation angle is obtained when the incident angle is equal to emergent angle. when light ray refracts through the prism. When light ray refracts through the prism. Now, okay, I will give a small understanding what's happening when I will explain a small idea. I will explain roughly what would happen when you increase I1 with the time. When you increase I1 with the time, I will explain what would happen for the R1, R2, I2. Roughly, I will explain. Then you will get an idea. Okay. Then you can understand this minimum deviation scenario also. Now, this is the idea. Okay. Right. Right. Okay. Now, what would happen? Okay. Right. Okay. Okay. Now you know that when we increase I1, very carefully listen. When we increase I1, we know that what would happen for R1? When you increase I1, what would happen for R1? According to Snell law, we know if I apply Snell law for refraction at first surface, I can say N1 sin I equals N2 sin R into sin R. Okay. Then you need to understand when, because when I consider my first surface, who is my N1 and N2? If I consider my first surface, surrounding medium air is my first medium, N1, the glass prism is my second medium. Then we know N1, N2 are constants for those two mediums. Unless we don't change the medium, N1, N2 are constants, right? And then we understand N1, N2 constant means sin I proportional to sin R. You understand? Sin I proportional to sin R. That means incident angle proportional to refractant angle. That means when I increase I1, understand R1 also increases. It's important idea. I'm increasing I1, R1 also increases. Then what would happen to R2? Can remember the equation A equals R1 plus R2 equation. A equals R1 plus R2 equation. From this equation, we know that always R1 plus R2 always must be a constant because prism angle is a constant. If we use the same prism angle can't be changed. Prism angle is a constant. R1 plus R2 should be a constant because of that. Now, I'm increasing my incident angle gradually from 30, 35, 40, 45. Likewise, relatively R1 increases. When R1 increases, what would happen for R2? R2 should decreasing. Why? Because always now, if this R1 value increases, in order to maintain addition of R1 and R2 a constant, when R1 increases, relatively R2 must be decreased. I1 increases, R1 increases, relatively R2 decreasing. When R2 decreases, what would happen for the I2? I2 also decreasing according to Snell. N1 sin I into sin R applied to second surface. Then you understand, you are increasing I1. You are increasing I1. Relatively, what would happen for the I2? What would happen for the I2? When you are increasing I1, I2 decreasing. I1 increases, I2 decreases at a certain instant. You are increasing, this is your I1. You are increasing I1, you are then automatically I2 decreases at a certain instant. What will happen? I1 becomes equal to I2. That instant where minimum deviation occurs. That means at the minimum deviation, I1 and I2 must be equal. Do you understand? I hope you understood. Okay. Highlight minimum deviation angle. Incident angle is equal to emergent angle. Highlight minimum deviation angle. Incident angle is equal to imaginary angle. Imaginary angle. Now again draw this diagram. And also understand now when we draw a general ray diagram for a prism, when light ray enters from the prism at first surface, emerges from the second surface, generally the ray diagram is not symmetrical. Not symmetrical about this axis passing through the prism. Yeah, for a normal situation, generally, this ray diagram is not symmetrical about the axis which bisect the prism angle. But at the minimum deviation, understand, the ray diagram is symmetric about the axis which bisect the prism angle. Okay, that's also important point. I will give that point. Now draw the diagram again. Okay, draw the diagram again. Okay, I raise and I draw it. Okay, we'll draw the diagram again. Incident angle. Now symmetric. Try to draw a symmetric diagram. Symmetric ray diagram. This is the angle bisector of prism angle. The axis. The prism angle is A, and this angle is A over 2, A over 2. Because prism angle is bisected by this axis passing to the prism. So this axis is the angle bisector of prism angle. Prism angle is A. Prism angle is A. Then A by 2, A by 2. Okay. Incident ray. Symmetry. Then you need to understand if the ray diagram is symmetric, very careful. In every point, there's an important point to understand. Now, I told you, now at the minimum deviation, I1 is equal to I2. Okay. If your I1 is equal to I2, what can you say about R1 and R2? They also must be I1 equals I2, R1 equals R2. Then you should obtain a symmetrical ray diagram about the axis which bisect the prism angle. Then my question is, the refracted ray from the first surface should be horizontal or inclined. Reply in chat box. I1 equals I2, R1 equals R2. Now, the axis passing through the prism angle bisect the prism angle. The refracted angle from first surface should be horizontal or inclined. Any answers? Any answers? The ray diagram must be symmetric about that axis which bisect the prism angle. It should be, the refracted angle must be horizontal. Then only there will be a symmetrical diagram. Always understand at the minimum deviation. At the minimum deviation, refracted angle, refracted ray is horizontal. Because when you draw somewhat inclined refracted ray, do you think about this axis? This diagram is symmetric? No, right? In order to obtain a symmetric ray diagram, always understand refracted ray. Refracted ray must be horizontal. Important point. Then emergence. Then this normal is the normal. You know, this time I1, I2 equals R1, R2 equals. Now this case. Now write down here I1. Now here I1 equals to, I say I. I1 equals to I. I2 also equal to I. Then they are equal. This I2. Normal. This I2 also equal to I. R1. This angle is R1. R1 equals to R. This angle is R2. R2 equals to R. R2 equals to R. Okay. Write down. So once you finish writing, raise your hands. Once you finish writing, raise your hands. Raise your hands. So we'll take a break at 12. Now I will ask one question. Now we understood that the minimum deviation, I1 must be equal to I2, R1 must be equal to R2. The ray diagram must be symmetrical about the axis which bisect the prism angle. Then refracted ray must be horizontal. What can you say about the angle of deviation at first surface, D1, and angle of deviation at the second surface, D2? They also must be equal. Am I correct? Because I minus R, I minus R. Because I1, I2 equal, R1, R2 equal means angle of deviation at first surface must be equal to angle of deviation at second surface. Am I correct? Okay. So then, okay. Now write down at the minimum deviation. Important point. At the minimum deviation. Write down at the minimum deviation. At the minimum deviation. I1 equals I2. I1 equals I2. So important point. I1 equals I2. I1 equals I2. I say it is I. R1 equals R2. I say it is R. At the minimum deviation. Therefore, next line, therefore, angle of deviation at first surface. So therefore, angle of deviation first surface. This is ABC. ABC first surface. Second surface. Therefore, angle of deviation first surface. Angle of deviation at first surface. Let's say D1. Let's say D1. Now, you know, D1 is generally, D1 means I1 minus R1. You know, D1 means, you know that, D1 means I1 minus R1. This time I1 equals to I, R1 equals to R. So we can write down D1 as I minus R. Write down. And highlight this D1 equals I minus R, highlight. And D2, angle of deviation at second surface. Mark down D1, D2. This is D1. The diagram mark D1. D1. D2, mark down. Okay. Next point, angle of deviation at second surface inside the bracket AC. Angle of deviation at second surface inside the bracket AC. Angle of deviation at second surface. I say D2. Then d2 will be v2. We know the d2 equals I2 minus R2. I2 minus R2. Now we know I2 is equal to I, R2 is equal to R. Then d2 is same as I minus R. I minus R. d1 is also I minus R, d2 also I minus R. Then what can you say about the angle of deviation at first surface and second surface? They are equal. They are equal. Okay, once you finish writing until here, red color pen write down. Once you finish writing until here, red color pen write down. Red color pen. Red color pen. So this is the last theory sections that we are doing. Okay, then we can finish this in today. Then we'll do questions. Now, whatever the things I do in the physical class, I do same thing, same knot, same way I'm doing for online. Okay. Practicals, those things, you have a small disadvantage. Other than that, I do the practicals. Don't worry, I do all the practicals. You don't need to worry about that. But online, through online. Red color pen write down. At the minimum deviation, comma. At the minimum deviation, comma, red color pen. Angle of deviation at first surface. Angle of deviation at first surface. Angle of deviation at first surface is equal to angle of deviation at second surface is equal to angle of deviation at second surface is equal to angle of deviation at second surface. Right. Write down d1 equals d2 and box it. d1 equals d2, box it. d1 equals d2. Highlight the d2. Then, till we can't do questions, still we have to learn something. Okay. Now we'll write down important points regarding minimum deviation. At the minimum deviation, write down. At the minimum deviation. Number one, first point. At the minimum deviation, number one, first point, write down. Incident angle equals emergent angle. That means I1 equals I2. Incident angle equals emergent angle. Because what is our incident? This is our incident angle. This is our emergent angle. At the minimum deviation, number one, incident angle equals emergent angle. First point. Inside the bracket, you can put I1 equals I2. Inside the bracket, you can put I1 equals I2. Second point, write down. Second point, refracted angle at first surface. Refracted angle at first surface. Refracted angle at first surface equal to incident angle at second surface. Incident angle at second surface. Now, this is the refracted angle at first surface, R1. R2 is the incident angle at second surface. Inside the bracket, R1 equals R2. R1 equals R2. A third point, write down. Angle of deviation at first surface. Angle of deviation at first surface equal angle of deviation at first surface equal angle of deviation at second surface. Angle of deviation at second surface. Fourth point is important. Red color pen write down. Fourth point. Fourth point, red color pen write down. Fourth point. Write down. Refraction is symmetric. Refraction is symmetric from both sides of the. Sorry, refraction is symmetric. Write down. Refraction is symmetric about the axis. About the axis. Which bisects the prism angle. About the axis which bisects the prism angle. That idea also done. Okay. Okay, now the last few things, then we can do questions. Okay, the last few things. Okay. A topic, right on topic, a topic based on these ideas. Now we can out. Already for a general situation, we derive the equations for prism. A plus simple D equals I1 plus I2. A equals R1 plus R2. For a normal general situation, we derive the equations. Now we are going to derive the equations for a minimum deviation scenario. Topic, relationship between prism angle and minimum deviation angle. Relationship between prism angle and minimum deviation angle. Topic, relationship between prism angle and minimum deviation angle. Now, first standard equation is, we know that I1 plus I2 equals A plus D. Okay. Right. Now we know that A plus D equals I1 plus I2 or whatever. A plus simple D equals I1 plus I2. That is a general equation. Now we know that at the minimum deviation, we know I1, I2 equal. I1, I2 equal to I. And we know simple D, deviation is minimum. Simple D, angle of deviation is the minimum deviation, capital D. We know simple D equals capital D. So therefore, we can write down. We can further alter this equation. A plus capital D equals I plus I. Therefore, A plus capital D equals I plus I. A plus capital D equals 2I. Okay. A plus capital D equals 2I. Important equation. Highlight this equation. A plus capital D. Here capital D means minimum deviation angle. A means prism angle. I means incident angle. Important equation, highlight. If I subject I can write down I as. If I subject I can write down I as A plus D by 2. A plus D by 2. This will be my equation 1. If I subject I will be A plus D by 2. This will be equation 1. And also we'll know that capital A, prism angle is equal to R1 plus R2. Then we know prism angle equals R1 plus R2. Next we know prism angle equals R1 plus R2. A equals R1 plus R2. At the minimum deviation, what we know? R1 equals R2. at the minimum deviation, we know that R1 equals R2, that is simple R. Then I can write down A equals 2R, R plus R. A equals R plus R, A equals 2R. Highlight another equation. If I subtract R, R will be A over 2. R will be A over 2. This will be my equation. Equation 2. Equation 1, I is A plus D over 2. Capital D. Equation 2, R equals A over 2. Okay. Now I'm deriving these scenarios for minimum deviation. This can be applied only for minimum deviation, these scenarios. Then, if I consider refraction at first surface, refraction at first surface, if I apply Snell. Now, refraction at first surface, that means AB. Means AB, okay? Snell law. Snell, N1 sin I equals into sin R. N1 sin I, N2 sin R. What is my N1? N1 means refractive index of the surrounding medium. Mostly it's here. N1 sin I, incident angle I, sin I know from my equation 1, I equals capital A plus capital D over 2. Sin A plus D over 2 from equation 1 must be equal to N2 sin R means from equation 2 R means A over 2, capital A over 2. From equation 2. Then I can write down N1 means refractive index of surrounding medium. N2 means refractive index of the prism. N2 means refractive index of the prism. N1 means refractive index of the surrounding medium. If you didn't write down this, write down. If I subject N2 to N1, I can write down N2 to N1 equals sin A plus D over 2 sin A over 2. This is an important equation. Okay, now normally, most of the questions, if they ask you to find, now sometimes in a question they give a prism angle of a prism, minimum deviation of that prism, and they ask you to find the refractive index of the prism. In that case, you want to apply N2 to N1 equals sin A plus D over 2 sin A over 2. You can directly apply this equation. There is no issue. Why? Because most of the times, most of the examples understand surrounding medium is always AR. That means, suppose your N1 is AR, refractive index of the prism equals to what? Sin A plus D over 2 over sin A over 2. Do you understand? If the surrounding medium is AR, okay? If the surrounding medium, if surrounding medium is AR, then we know what can we say about N1? N1 equals 1. Therefore, Refractive index of the prism. Refractive index of prism equals, that means simple n equals sine a plus t over 2 over sine a over 2. Raise your hands. Whatever I explained until here, if you understood, raise your hands. Understood? Raise your hands. Then finish writing until here. Now we'll do 1-2 question. Now theory wise, everything is finished. I want to teach you about this internal reflection through 9-degree angle prisms. I will explain that later. Today they will explain. I think we can finish prism today itself. I think right now. Then we do questions. Now once you finish writing this one, we'll do questions. Yeah, if you're finished, raise your hands. Once you finish writing, raise your hands. We'll take a break at 1 o'clock also. And every day I want you to write the paper. It's okay. It doesn't matter whether you can do the paper good or bad. Your marks is 5 or 10, it's completely all right. Come and write the paper. So once you finish writing, raise your hands. Today night, 7 p.m., there will be a discussion. After the 14 discussion will be from today, 7 p.m. onwards. If you finish writing, then we'll do some questions. Start doing question number in the tute. Start doing question number 41, 41, 42. Is 41, 42. Start doing 41, 42. I will give 2-3 minutes, then I'll start explaining. 41, then 42. 41, 42. 35, 37. 41, 42. 35, 37. 35, 37. 43, 46. 43, 46. 43, 46. Did anyone get the answer for question number 41 hands? Did anyone get the answer for question number 41 hands? No one. So I will give time. Now please remember these things, okay? A plus D, I1 plus I2, A plus D, 2Y. A plus capital D, 2Y. A equals R1 plus R2, capital A. At the minimum deviation, capital A equals 2R. At the minimum deviation, simple N equals sine A plus D over 2, sine A over 2, learn by heart then. Learn by heart then. So we'll discuss 41 first. Question number 41 says that right. The angle of glass prism, that means prism angle is 60 degree. Okay. 41, number 1. 41. Number 1. A prism angle is 60. Prism angle A equals 60. Minimum deviation of light through the prism is 39. Minimum deviation, that means capital D. Capital D is 39. Capital D 39. Capital D 39. Then I need to find refractive index of the glass. I need to find simple line. I don't know simple line. I don't know simple line. Then how can I find? Easy. One equation. N equals raise your hands. How many of you got the answer? How many of you got the answer? Raise your hands. One got the answer. Two got the answers. N equals direct application. Sine A plus capital D over 2. You know A, you know capital D. Sine A plus capital D over 2 over sine capital A over 2 over sine capital A over 2. This is the equation. When you substitute for A and D, you get the answer. Then here simple N will be sine prism angle capital A is 60. Sine 60 minimum deviation, capital D, minimum deviation will be 39 over 2 sine prism angle is 60 over 2. What is the answer? 60 plus 39, 99 over 2. How do you divide 99 over 2? How do you divide 99 over 2? 99 over 2 means you can't just divide like this. You can write it like this. 99 means 98 degree 60 minutes over 2. 98 degree, if you divide by 2, how much? 49 degrees. If you divide 60 minutes by 2, 30 minutes. Then sine 49 degree 30 minutes over sine 30. Sine 30 means half. Sine 30 means half. Simple and easy. Simple in. Here, what is the value? Then someone tell me what is the value for 49 degree 30 means? Someone tell me. What is the value for 49 degree 30 minutes? Someone tell me the value. Let me find the final answer. What is the final answer? Okay, at least final answer. Sine 45 degree 30 minutes. Okay, if you can't tell that one, tell me. Someone tell me the final answer. Final answer. Sine 30 means half. Sine 49 degree 30 minutes means one says sine 49 degree 30 minutes means one says 0.7604. Then this value is 0.7604. Sine 30 means half. That means 2 into 0.7604. 2 into 0.7604. That means 8, 0, 12, 15, 1.5, roughly 1.5. Refractive index is roughly 1.52. Raise your hands. How many of you got this answer? Roughly 1.52 hands. Roughly 1.52 hands. I think it's easy, right? Then number 2, we'll do number 2 and we'll take a break. Number 2, what they say? Refractive index of glass prism is 1.66 and prism angle 60. Find the completely same equation. Previously, they have given prism angle and minimum deviation. You found refractive index. Now they have given prism angle and refractive index. You want to find the D. Same equation. The number 2. Second case. Same equation. N equals sine A plus D over 2 over sine A over 2. Okay, now I want to find D. What is the refractive index of the prism? Refractive index, the prism is 1.66. Now 1.66, that means 1.66 means now, okay, 1.66 prism angle is 60. Okay. Now 1.67 means 4 over 3, 8 over 7. 8 over 7. Okay, it's okay. 1.66. 1.66 sine prism angle is 60, right? 60. I want to find now deviation D. Now deviation D over 2 over sine prism angle 60 over 2. Then 60 over 2 means sine 13. Then 1.66. Sine 30 means half, right? Sine 30 means half. Sine 30 means half. So I bring that sine 30 here. Sine 30 means half. Then multiply by half. Am I getting it? Because sine 60 over 2 means sine 30. Sine 30 means half. If I bring that half to the left side, 1.6 is into half. Sine 60 plus capital D over 2. 60 plus capital D over 2. Okay. Then 0.83 equals sine 60 plus capital D over 2. Please someone find me the corresponding sine angle of this 0.83 corresponding to which sine angle? Can someone tell me? Can someone tell me which sine angle corresponding to 0.83? Can someone tell me quickly? Can someone tell me? Is it 56 degrees 6 minutes? Are you sure? 0.1 says that 0.83, this value corresponding to sine 56 degrees 6 minutes. One says that this value corresponding to sine 56 degree 6 minutes. Check, you guys to check with that, okay? Sine 60 plus d over 2. 60 plus d over 2. Now understand, now I converted both sides in sines. I converted both sides in sines, therefore I can remove sine. I can remove sine. I can't cut sine, but I can remove sine. And when I remove the sine, what it remains? 56, 56 degrees 6 minutes equals to 60 degree plus d over 2. Then if I move this to this side, 56 degree 6 minutes into 2 must be equal to 60 plus d. Then my d equals 56 degree 6 minutes into 2 means how much? 56 degrees 6 minutes into 2 means how much? 12 minutes 112 degrees. 12, 12, 112 degree 12 minutes minus 6 degrees. Then we are ending with how much? 12 minutes 52 degrees. Raise your hands. How many of you got this answer? How many of you got this answer? Hands up. Got this answer? Hands up. Okay, whatever I taught you until now, we started at, I think, not 10:30, 10:45 roughly. We started roughly at 10:45, 10:45, 11:45, 12:45. Now it's 1. It's been, raise your hands. Whatever I explained until now, if you understood, raise your hands. I understood everything. If you understood everything, raise your hands. If you understood, raise your hands. Okay. Now we'll take another break. Now time is already 1:05. Come at 1:15. Then 2:15, 2:45. We are doing more, again until 2:45. 2:45. If it is possible, we'll do until 3. 2:45. Yes, we have 1:15, 2:15, 2:45. Yes, take a break and come at 1:15. We'll do until 2:45, 3. Take a break and come. Eat something, drink something, eat something and come. Right. Okay. Now, once we finish doing question number 41, we'll start doing 42, 35, 37. 42. It says that find the emergent angle. Find the emergent angle and the angle of deviation of a light ray incident with an incident angle 36. Now, this time we don't say anything about minimum deviation. Okay. Emergent angle. Emergent angle means I2. Angle of deviation of a light ray incident with an angle of incidence of 36 on a glass prism, refractive index 1.4. Prism angle 40. I think we want to find the emergent angle I2, then we want to find angle of deviation, simple D. We want to find I2 and simple D. The given data, I1 is given, incident angle, I1 is 36. Refractive index of the prism is given as 1.52, prism angle 40. Given data. Question number 42. A is given, prism angle 40. Refractive index 1.54. 1.54. Incidence angle I1 36. I1 36. What we need to find? I2 and simple D. I2 simple D we need to find. Then how can we do this one? How we can do this one? I know I1. I want to find I2. Start doing this one. Because now we know two equations, A plus simple D equals I1 plus I2, A equals R1 plus R. Now one can think that, okay, we'll use A plus simple D equals I1 plus I2 equation, we'll try to solve. If not, you guys might think that, okay, we'll use A equals R1 plus R2. Now there are two equations also. A plus simple D equals, this is not the minimum deviation scenario, okay? So you can't apply minimum deviation equations right now. A plus D equals I1 plus I2, one equation. Second equation is A equals R1 plus R2. But the problem is I know A and I1. I know A, I know I1. Even if I'm going in this equation, I know A, I know I1, but I don't know D and I2, I don't know. I know A, but I don't know R1, R2, R1, R2. So in that case, what we need to find is, now you want to apply Snell law and you want to find R1. Apply Snell law for the first surface of the prism and try to find R1. So once you found R1, you can easily find R2 from this equation because you know A. Once you found R1, you can easily find R2 you use this equation. Once you know R2, again apply Snell law for the second surface, you can find I2. If you know I2, you can find the deviation. Do it quickly. Don't waste the time, do it quickly. Question number 42. Okay. Now for your understanding, if I draw a prism, now incident angle, normal. I know this I1. This is my I1. I don't know R1. and I don't know R2. And actually, I want to find I2 and D. I want to find I2 and simple D. So this is my first surface. At first surface, Snell. At first surface, if I apply Snell law, N1 sin I into sin R. N1 sin I into sin R. Into sin R. Now, if unless they didn't specifically mention what is the surrounding medium, always surrounding medium is here. So N1 is 1. N1 is 1. Sine incident angle, sine I. Incident angle I1. Sine I1 is 36. Sine 36. Refractive index of the prism is given 1.54. 1.54 sine. I want to find R1. R1. Then sine 36, I want to find R1. Then what is the R1 value? When you found this, did anyone find the R1 value? Did anyone find the R1 value? If you found the R1 value, put the answer chat box. Did anyone find the R1 value? Sine 36, you should have the sine tables. Then you should have a logbook. What is the value for R1? R1, one says that 22 degree, 26 minutes. One says 22 degree, 26 minutes. Okay. Yes, 22 degree, 26. That's correct. 22 degrees, 26 minutes. That's correct. So when you simplify this, you will get that R1, 22 degree, 26 minutes. And once you found R1, now you can find your target is finding I2. Now you know R1, you know A. Now you can find R2 easily. You can find R2 easily. Find R2. Now we know that A equals R1 plus R2 equation. Now we know that A is how much? 40. A is 40, right? A 40. R1, I want to find R2. R1 is 22 degree, 26 minutes. Plus R2. Plus R2. When I subject R2, I can get. When I subject R2, R2 will be equal to 40 degree minus 22 degree, 26 minutes. Then my R2 will be 26 minutes. How do I subtract 40, 22 degree, 26 minutes from 40 degree? Then 40 degrees means 39 degree, 60 minutes. 39 degree, 60 minutes. I want to subtract 22 degree, 26 minutes. Then here I'm getting here 34 minutes, 17 degree, 34 minutes, my R2. That's my R2. Then once you found R2, now you can find I2 easily. Again, apply Snell law for second surface. At second surface, apply Snell law. Snell law. N1 sin I into sin R. N1 sin I into sin R. This time second surface, N1 means refractive index of glass prism. At the second surface, glass is the first medium, surrounding AI second medium. Refractive index of glass, how much? 1.54. 1.54 into incident angle, R2. I know incident angle is R2. R2 is 17 degree, 34 minutes. Sine 17 degree, 34 minutes must be equal to N2 means 1. N2 means 1. Sin R means I2. Sin I2, finally. Sin I2. What is the value? What is I2? Can someone reply what is I2? When you simplify this, what is I2? I2 equals finally. I2 equals, one says that 27 degree 42 minutes. 27 degree 42 minutes. One says 27 degree 42 minutes. So when you simplify this, you will end up with 27 degree 42 minutes. That's your I2. Then I found I2 done. Now I need to find simple D. Now you can substitute for the equation. Now I know I1, I know I2. I1 is 36, I2 is 27 degree 42 minutes. I know A is 40. Simple D I want to find. A plus D equals. A plus D equals I1 plus I2. I1 plus I2. Then my A is how much? A is 40. So I want to find simple D. What is my I1? I1 is 36. I1 36. My I2 will be 27 degree 42 minutes. Simplify. If I move this 40 to that side, minus 40. Then 36 minus 40 means minus 4. 27, 42 minus 4 means 23, 42. Raise your hands, how many of you got 23 degree 42? Raise your hands, how many of you got minimum deviation? Sorry, not minimum deviation, angle of deviation as 23 degree 42 means answer. 23, 42, hands up. That's an answer. Then that question done, 41 done, 42 done, now 43. Start doing 43. Start doing 43. Start doing question number 43. 43. Certain prism produces minimum deviation of 51 and a deviation 62, 48 for two values of incident angle 46, 82 to determine the angle of refraction of the prism. Now it should be, now that's a mistake, I think. Determine the angle of refraction of the prism. It should not, it's wrong, I think. Determine the prism angle, I think. Now the question says that determine the angle of refraction of the prism. That's wrong, I think. They're asking determine the prism angle, okay? Question number 43, determine the prism angle. It's not angle of refraction of the prism, it's wrong. Okay. So there is a mistake, I think. Give me a second. I will check with that. Question number 43. Okay, now you guys are 43. You guys try doing 43, okay? Don't do 35, 37. We'll do it later. Now do 43. Okay? Do 43. You do 43. So yeah, in question number 43, you want to find prism angle A, and then you want to find the refractive index of the prism. Okay. So you want to find the prism angle, the refractive index of the prism. Okay. Now in question number 43, Now, given data, understand, given data, minimum deviation is given. Capital D is how much? 51. That is minimum deviation. And they have given deviation, just angle of deviation and corresponding incident angles. Minimum deviation is 51. In addition to that, they have given two incident angles which provides angle of deviation how much? 62 degree 48. Okay. So there are two possible incident angles which provide angle of deviation 62 degree 48 minutes. Those angles are 40 degree 6 minutes and 82 degree 42 minutes. Okay. Then simple D is given. Simple D is how much? 62. When the deviation is 62 degrees, 48 minutes. When the deviation is 62 degree 48 minutes, corresponding possible incident angles are what are those? 40 degree 6 minutes. The other possible incident angle will be 82 degree 42 minutes. 82 degree 42 minutes. Okay. What we need to find the question? In the question, we need to find prism angle A. Prism angle A. Then incident angle at the minimum deviation. At the minimum deviation, incident angle line. You know that I1 equals I2 at the minimum deviation. At the minimum deviation, incident angle I. Then refractive index of the prism. You need to find three variables. Now we can easily find A. We know the equation. A plus D equals A plus simple D equals I1 plus I2. I know deviation, corresponding incident angles. I can find A. So my A will be 62 48. I1 is 40 degree 6 minutes plus 82 degree 42 minutes. When you add these two and when you subtract, what is the answer? 82 plus 40 means 122. 122, 42 means 6 means 122 degree. This is, when you add these two. 122 degrees 48 minutes. If you move this one that side, minus 62 degree 48 means you will end up with how much? Exactly, prism angle is 60 degree. Raise your hands, how many of you got prism angle as 60 hands up? 60. Got 60. Got 60 prism angle hands up. Got 60. Yes, it's easy, right? It's easy. Okay. Then A done. Then we want to find I. Then we want to find I, then minimum deviation. What is that I? I means incident angle at the minimum deviation. Then you know prism angle, you know minimum deviation. Can you remember A plus capital D equals 2I. A plus capital D equals 2I. I think you can remember this equation. From this equation, we can write down A is 60. Minimum deviation is how much? Minimum deviation 51. 2I. That's what I want to find actually. Then here 60 plus 51, 111 over 2 means. 111 over 2 means how much? 111 over 2 means I can write down 111 as 110 degree 60 minutes. If I divide by 2, 55 degree 30 minutes. 55 degree 30 minutes. That is I. Now simple in. Now you know A, you know capital D, you can use that equation. N equals A plus capital D over 2 over, sorry, N equals sine capital A plus capital D over 2 over sine capital A over 2. Next equation. N equals sine capital A plus capital D over 2 over sine A over 2. This equation. Then what is the answer? Sine capital A is 60, capital D 51 over 2 over sine 60 over 2. 60 plus 51 over 2 means how much? 60 plus 51 over 2 means how much? Sine I. I is how much? 5530. Sine 5530 over. If I write it, N equals sine 55 degree 30 minutes over. Sine 30 means sine 30, 60 over 2 means sine 30. Sine 30 means half. What is the answer? What is the answer? 1.6482. I think one student got 1.6482 as the answer. That's it. These questions are not difficult, right? Because I explained the theory in that way. It's really, even you come for the class, if you could not do or if you could not understand the questions, that's a problem. But I think all of you understand what the way that what I'm teaching, right? That question also done. That is also done, discussed. So then start doing question number 46. Now 46. Okay. Forty-six. Then you want to find in that question, emergent angle means I2 and angle of deviation means simple D. You want to find I2 and simple D. You want to find I2 and simple D. It's a good question. You want to find I2 and simple D. It's easy, right? Okay. Now we'll do that question also. So 145. Question number 43 also done. Question number 46. Okay. Question number 46. Okay. 46. Now, if I draw the prism, you can learn something from every question. Most of the questions are not substitution questions, but you can learn something. It's a prism. Now, when incident angle, now they have given two cases. When your incident angle, that means I1, when your incident angle is 0, they are asking something. When your incident angle is 90, they are asking something. So first of all, I will draw for when incident angle 0. You know that incident angle is measured from the normal. Incident angle is measured from the normal. Incident angle is measured from the normal. Then when incident angle is 0, when incident angle is 0, how would you draw the ray? Incident angle is 0 means this is my normal. This is my normal. If incident angle is 0, is my normal. If the incident angle is 0, how would you draw the ray? That is important. How would you draw the ray? Incident angle 0 means how would you draw the ray? How? Give me a second. Okay. Now, we'll do like this. This is the normal. Prism angle 60. Okay. Now, incident angle is 0. If incident angle is 0, the light ray is perpendicular to the norm, perpendicular to the first surface. When light ray enters perpendicular to the first surface only, incident angle is 0. Okay, I1 is 0. Am I correct? Perpendicular. Then what would happen? Prism angle 60. This angle also 60. Okay. This angle is 90. Then this angle also, this angle also should be 60. Okay. This angle is 60. And this angle is 60. Now keep on doing. Now they're asking a ray of light falls at incident angle of I on 60-degree prism angle of refractive index 1.5. Find the emergent and angle of deviation of the ray for the cases I equals 0. Now this consider this triangle as equilateral triangle. That means all three sides of the prism is same. The triangle, all the sides of the triangle is same. Therefore, angles are same, 60, 60, 60. If that's the case, when your incident angle is 0, understand, when your I is 0, am I correct? When your I is 0, light ray is perpendicular to the first surface. Because we start measuring the angle from the normal. For an example, if there's a light ray like this, we start measuring the angle from the normal to the incident ray. If your angle is 0 means light ray is perpendicular to the first surface. Therefore, there is no deviation from the first surface enters to the third surface like this. Then first of all, find what would happen now. Now you want to decide whether this light ray will refract to the surrounding or this light ray undergoes total internal reflection. No, you want to decide. In order to decide that, you need to find the critical angle for this glass air interface. Find the critical angle. So we can find the critical angle sin C. Sin C equals refractive index of rare medium over refractive index of denser medium. Now we assume surrounding medium is air. In that case, sin C. In that case, sin C will be refractive index of rare medium is air. Refractive index is 1. Refractive index of denser medium, that is glass 1.5. Someone tell me what is the critical angle for this glass air interface? C equals how much? Can someone reply C equals how much? C equals 41 degree 14 minutes. 41 degree 14 minutes. But look here, critical angle for glass air interface is 41 degree 14 minutes. What can you say about the incident angle? Now, glass to the air incident angle is 60. Critical angle is 41 degree 14 minutes. That means incident angle is greater than C. Because 60 is larger than 41 degree 14 minutes. Therefore, incident angle is larger than critical angle. Then I taught you what? If your incident angle is larger than critical angle, I taught you that light ray undergoes total internal reflection. Light ray undergoes total internal reflection. Okay. Like this. Like this. Okay, like this. Okay. So then this angle also 60. This angle also 60. And this is the normal. Then what should be this angle? This angle is 60. Okay. Then this angle is 30. Okay. That means what can you say about this angle? Okay, I made a mistake. Okay. Look here. Now this angle is 60. Then this angle is 30. Am I correct? This angle is definitely 60. Equilateral triangle 60. And this angle is how much? This angle is 90. This angle 90 means your light ray emerges from the second surface also perpendicularly. Your light ray emerges through second surface also perpendicularly. Raise your hands. Did you understand what I explained in this question? Raise your hands up to now. Up to now, if you understood, raise your hands. Why I drew my incident ray this way, normal to the first surface, and why I drew my emergent ray also normal to the second surface. If you understood why, raise your hands. If you understood, raise your hands. You guys understood, right? Okay. But they are asking in the question. They are asking the question. They are asking 46. Find the emergent angle. That means I2. Now I2 means now I1 is also 0. Why? Incident ray is perpendicular to the surface. I2 means refracted angle. What is your refracted angle? This is your normal. This is your normal. Light rays in that direction. Light rays emergent rays perpendicular to the second surface. Reply in chat box. What must be emergent angle? What must be I2? Reply in chat box. Now, emergent ray is perpendicular to the second surface. What must be the I2 value, emergent angle value? Tell me. What must be emergent angle value I2? Whether it's 90 or 0. Everyone reply. It's okay. Because there are two possible. If you get it, there is one answer, but you can think two answers. Whether it's 90 or 0. Everyone reply. What must be the emergent angle I2? Emergent angle I2 must be 0. Therefore, I2 is 0. So I2 is 0. Then they are asking they are asking deviation angle. Deviation angle is how much? Deviation, okay, I'll ask from you that one also. I2 is 0. Emergent angle is 0. What can you say about the deviation angle? Reply, chat box. Deviation angle. Deviation angle. Deviation. Always check the initial direction of the light ray and final direction of the light ray. Initial direction is in this direction. Final direction is in this direction. Deviation is exactly 90 degrees. Deviation 90. Deviation 90. It's a good question. Okay. Now next case is when I equals 0, we found the emergent angle I2 as 0, deviation as 90. Now again you want to find the same scenario for when your incident angle is 90. Start doing that one. How many of you started getting the values when incident angle is 90 hands up? How many of you started getting values when your incident angle is 90 hands up? Hands up. Do we do it now? Maximum now time is 1:55. We will do the class maximum until yeah, time is 1:50. Maximum we will do the class for 50 minutes, 55 minutes maximum. Today we are finishing Prism also actually. Today we are finishing Prism also. Okay, we'll do like this. Then we'll do the Okay. So we'll discuss the remaining theory and we'll come to the questions again. We'll discuss remaining theory and we'll come to the questions again. Okay. Right. Mm, Okay. Right. Now put your topic. Topic. Okay. We'll discuss the remaining. I want to discuss 46 another part, and 35, 37 we'll discuss them. Before discussing them, we'll discuss remaining theory sections. There is no that much of theory. Put your topic. Prisms which do total internal reflection. Prisms which do total internal reflection. Okay. Topic. Prisms which do total internal reflection. Red color pen, write down. All isosceles right angle prisms. All isosceles right angle prisms do total internal reflection. Do total internal reflection. Do total internal reflection. Now put case one. Now put case one. We are talking about right angled isosceles prisms. We are talking right angle isosceles prism. Okay. Right. Now draw this diagram with me. I am considering right angled isosceles prisms. Then any right angle isosceles means I think two sides equal. Okay. Right angle means definitely one angle is 90 degree. Isosceles. Then what can you say about the remaining two angles? Definitely 45 degree, 45 degree. Am I correct? Okay, that is one important point. Okay. Now draw this prism. Case one. Right angle. Now, let's say now this angle is 90, this angle is 45. This angle will be 45. Now, when you keep an object, in front of this face, in front of this height, okay, it's an object. Now, talking about this object, the top point of the object I represented as an arrow. This is the bottom. This is the bottom point of the object. Very carefully say object. Object. Then we know light. Okay, I draw that object. Somewhere here. This is my object. Now, how we see objects? Because objects emits light from the object to our eye, then only we are able to see the objects. So therefore, I am drawing two light rays coming from the object. One light ray comes from the top point of the object towards the prism. Other light ray comes from the bottom point of the prism. Bottom point from the object to the prism. One light ray coming from the top point of the prism, top point of the object. The second light ray coming from the bottom point of the object toward the prism. Okay. Okay, right. If I draw those two light rays, use two different colors to draw two light rays. Use two different colors to draw two light rays. The top light ray coming from top point of the object, perpendicularly. Then we know that when this light ray enters from first medium to second medium perpendicular way, then there is no deviation incident at this point. Okay. Then this is my normal drawn to this surface. Normal drawn to the surface. Normal drawn to the surface. Then this angle 45, this angle 45, this angle must be also 45. This angle is 90, this angle 45, this angle also must be 45. And this angle must be 45. This angle also must be 45. This angle also must be 45. Now you guys know generally now, depends on the, even understand when you consider glass, there are also variations of glasses. So there are many types of glasses, but normally refractive index of glass is about 1.5, sometimes 1.52, 1.53, 1.58. But normally refractive index of a glass we consider as 1.5. And when you find the critical angle for glass air interface, very carefully understand, critical angle for glass air interface, critical angle is you found, what is the value? 41 degree 48 minutes. Very carefully listen. Critical angle for glass air interface is normally, this value can be changed, but generally critical angle for glass air interface. Critical angle for glass air interface is 41 degree 48 minutes. Now this light ray perpendicularly entering from the first surface, incident to the second surface. Now what can you say about the incident angle? Incident angle is 45. That means incident angle is greater than critical angle. Sorry, incident angle is greater than critical angle. Then what will happen at this point? Light ray undergoes total internal reflection. There is no doubt. Incident angle is 45, but critical angle is 41. Therefore, light ray undergoes total internal reflection. Then this is 45 means the reflected, not refracted, reflected angle also must be 45. Then the light ray entering horizontally after reflection from the surface, the reflected ray must be going vertical downwards, right? 45, 45. Reflected ray must be going vertically downwards. Then this angle also 45. This is tested many times in your exams, 45. Okay. What is this red color one? Red color one is the light ray coming from the topmost point of the object. Then I will draw a light ray coming from the bottommost point of the object using blue color. Same idea, same concept. Horizontally. Horizontally. Angle is same as 45. Then greater than critical angle. Total internal reflection. Like this. Then, okay. Now you are looking from this side. Okay, you are looking from this side. Okay, your eye is here. So when you look from this side, this blue color ray corresponding to bottommost point, red color line corresponding to topmost point of the object. Am I correct? Blue color corresponding to bottommost point of the object, red color corresponding to topmost point of the object. Then you can see a virtual image. You can see a virtual image this way. Okay, this is an image. Image of this object. Did you understand? Raise your hands once you understood. Did you understand? Raise your hands if you understood A, B, C. If you understood, raise your hands. Okay. Did you understand? What about others? Didn't you understand? Okay. All right. Draw this diagram quickly. This diagram, there is case one. And this time, now, under case one, I kept the object in front of this face. In case two, I'm going to keep my object in front of this face. I'm going to keep my object in front of this face. Case one, draw the diagram. If I draw for case two, this angle 90. This angle is 45, 45. 45. This angle 45. This angle 45. 45. Now, if I keep now the case one, in case one, I kept the object in front of first surface, this surface, AB surface. Now I'm going to keep my object in front of AC surface. This is A, this is C, this is B. This is my object. Then what would happen? The light ray coming from the top undergoes total internal reflection like this. Incident at this. Now look here, normal. You know why? You know why this light ray undergoes total internal reflection? Very similar to this idea. Because this angle is 45, this angle also 45. Okay, mark all the angles, okay, 45. Mark this angle also 45. Then what would happen when this light ray incident at the surface now? The object placed in front of AC surface, light ray undergoes total internal reflection from AB surface. Again, light ray enters to BC surface. Then what would happen for the light ray entering at BC surface? Again undergoes total internal reflection. Again undergoes total internal reflection. This angle is 45. Again undergoes total internal reflection. Now, reflected angle must be 45. That means this time your light ray is horizontal again. This light ray is horizontal again. This light ray is horizontal. That means perpendicular to first surface, leaving perpendicular. Do you understand? That means when you compare, when you keep an object in front of AB surface, there was only one internal reflection. Internal reflection occurs only from one surface, that is AC. But when you keep this object in front of AC surface, internal reflection occurs at two times. From AB surface also there is internal reflection. When light ray enters to BC surface, in there also there is an internal reflection. And comparing with these two cases, there is one internal reflection in this diagram. There are two internal reflections in this side. Now raise your hands. How much of you understand this horizontal one become vertical down becomes horizontal left hand side? Really, if you understood, if you really understood, please raise your hands. That idea. This blue color one also same. Put the diagram nicely. I will give some time. Blue color one also same. This way, this way, this way. Mark down the, please mark down these angles. 45, 45, 45. Mark down angles 40, 40, 45. Then when you look from the here, when you look from here, you see an image this way. Image. Mark them. Then there is one more case. Once you finish drawing, raise your hands. Once you finish drawing, raise your hands. Now, orientation of the image in the sense, what did you mean now? That's why I have taken the light ray coming from top point of the object in red color, light ray coming from bottom point of the object in blue color. If you see the object from BC surface, suppose you should be able to see an image. Definitely, when you look from the BC surface, you will be able to see an image, right? Then, when you extend this red color ray backwards, and when you extend this blue color ray backwards, you will be seeing an image in this direction because red color one belongs to top point, blue color ray belongs to bottom point. Then you will be able to see an image in this way. Head is here, leg is here. That idea. If you are seeing for the same side, then top point belongs to red. That's the idea. Okay. Okay, then case number 3. Now, when you place an object in front of AB surface, this is how the diagram. When you place an object in front of AC surface, there will be two internal reflections. Here, one internal reflection. And again, when you keep your object in front of AB, AC, now BC surface. Now in front of BC surface, so AB this way. Now in this way, okay. Now we are keeping the object in this way. Right. Like this. This is your prism. 45 degree, 45 degree, 90. This is your prism. This angle is 90. Now, when you keep the object this way, vertically this side, somewhere here, if you keep the object somewhere here, like this, then how would you draw the graph? How would you draw the diagram? Then this angle 45. This angle also 45. Then if I draw, keep the object here, somewhere here. Then red color one belongs to top point of the object. Normal. Incident at first surface normal. Then refracts toward the normal. Refracts towards the normal. Okay. Now the problem is, now I could explain exactly at the surface when this light rays incident at the surface AC. I could explain. I explained there will be a total internal reflection because incident angle 45 larger than 41, 48. You also agreed because when you when you check the angle, this angle, when you calculate this angle, automatically you understand this angle is 45. Then in this case also you need to understand this incident angle is greater than 45. Okay. I can explain why when this light ray incident at incident at AC surface, this incident angle is definitely greater than 45. These cases, incident angle is 45. This case also, incident angle is at 45. But in this case, understand this incident angle, this light ray incident at AC surface with an angle of more than 45. I can explain why, but I will explain later. Even you can also think why the angle is more than 45. Think wisely. I will explain later. Now, this angle is more than 45, definitely greater than critical angle. So, therefore, this ray also undergoes some kind of internal reflection. This ray also undergoes some kind of internal reflection. Now, think that this angle is greater than 45, then definitely this light ray undergoes internal reflection. Internal reflection. Okay. Internal reflection. Okay. Then this light ray enters a BC surface. Then this light ray enters BC surface. Once this light ray enters to BC surface, normal, understand the refracted ray will become again horizontal. I will explain why later. The refracted ray will become again horizontal. If I draw for corresponding the light ray corresponding to bottom point of the object, same idea, parallel. So when I explain, you will understand, don't worry. But normally classes, they don't explain these things detailed. You might also have experienced that if you are going for any other classes, if you have gone for the classes. Then when you keep your eyes here, because you want to keep eyes where light rays coming towards you. The place where light rays comes towards you, you want to keep your eyes. Then you can see an image. You can see an image this way, downwards image. First of all, draw the diagram. First of all, draw the diagram. Once you finish drawing the diagram, let me know. Once you finish drawing the diagram, let me know. Then you might have a problem how you exactly see these emergent rays are horizontal. You might have a problem. I will explain. Once you finish drawing, I will explain. Oh, it's not important to explain also. Today, 7 p.m., there will be a discussion, paper class discussion. Please don't postpone. Whenever you can join live, please join live. Because not only for you, even I postponed. Difficult to do it again. Now I have target for 13, 14, 15 paper. Therefore, don't postpone anything. If you can join live, please join live. Don't always think I will always watch recordings. I will watch recordings. Don't thinking that way. When you join live and when you cover it, then there won't be any stress also. Then when you have a recording and you keep on thinking we'll watch the recording later, every day you keep on thinking that I couldn't watch that recording, I couldn't watch the recording, I want to watch that recording. So that is some kind of stress for you. Okay. Rose diagram quickly. The summary is now understand these two cases, there are only one total internal reflection. But this side diagram, there are two total internal reflections. So somewhere else write down. One internal reflection, two internal reflections, one internal reflection. That is important. Now, roughly, I explain. Now, first thing is, I will tell you why this is horizontal. I will tell you roughly. This thing, this angle as this angle is, let's say, I1. This angle is I1. So I draw for this angle is also I1. This angle also I1. This angle also I1. And this angle is R1. I say this angle as R2. Then if there is a total internal reflection from AC surface, this angle must be R2, R2, because at the total internal reflection, incident angle and reflected angle both are equal. If this is R2, now if this is R2, this angle is R1. R1, this angle is R2. This angle is R2, this angle is R1. R1, R2, R2, R1. If this angle is R1, this angle is I1 horizontal. This angle is R1, this angle must be I1 horizontal. That's why it's horizontal. Okay, you check why this angle R2 is larger than 45. You check and it's not important. You just check with that and tell me. Okay, that section also done. Raise your hands. Did you understand this idea, hands? Understood, hands up? Understood. Now we are going to finish Prism. If you understood, hands up. We are going to finish Prism. That is also done. That section also done. Now, okay, that is also done. Case number 2, case number 3, that is also done. Okay. Okay. The last important theory. Now you might have seen that when generally light ray, when white light ray passes through a prism, you might have learned in your school all level time period that light ray divides into 7 colors: red, orange, yellow, green, indigo, violet, something like that. Now we'll talk about that idea also. Why this light ray is separating to different colors when white light ray passes through a prism, we'll try to understand the reason behind that. Okay. Now put the last topic, last theory topic, last theory topic. Passing of white light through prism. Passing of white light through a prism. Passing of white light through a prism. Okay. Okay. Now, sometimes even you learned this in the classes. Sometimes they didn't teach you this properly. Okay. So I'm teaching you this with the best explanations. Keep your focus and listen. Sometimes teachers, they don't describe the reason behind the what white light ray divides to few colors, the reason. They don't usually explain the reason. Okay. That's what I write down. The refractive index for medium, write down a point. The refractive index of a medium is depend depends okay, my bad. The refractive index of medium depends on the wavelength of the light. The refractive index of medium depends on the wavelength of the light, and different wavelength experience and different wavelength experience different interactions with the atoms or molecules in the medium Okay, I will explain. Don't try to explain. Next point. Therefore, light rays with different wavelengths. Inside the bracket, different frequencies. Close the bracket. Have different refractive indices in a certain medium. Red color pen, right on next point. The speed of light in a medium depends on refractive index. Okay. Now listen carefully. Now, up to now, I think you also got the idea in this refractive index. If I ask you what's refractive index, now I taught you. Refractive index is some kind of physical quantity, physical parameter, which measures the deviation of a light ray when entering from one medium to other medium. The physical quantity which measures the deviation. That's how you know about refractive index. Okay. Then you thought, sometimes you have an understanding, you think that then refractive index depends on the medium. Different mediums, yes. Now, the knowledge that you have right now, whatever the things that I learned, whatever the things that I taught you, with that knowledge, you think that refractive index means the parameter which measures the amount of deviation when light ray enters from one medium to other medium. And refractive index depends on the medium. That means different material have different refractive indices. Okay, that's fine. But now, throughout the lesson until now, light ray means we talk about light rays. We consider light rays, and we did the questions. But you need to understand light rays are electromagnetic waves in the electromagnetic spectrum. If I ask you how many electromagnetic waves in the electromagnetic spectrum, what is the answer? Put the answer in the chat box. How many electromagnetic waves in the electromagnetic spectrum? Put the answer in the chat box. How many electromagnetic waves in the spectrum? Any answer? No answers. Quickly, we are going to finish the class now. 2:30. 15 minutes, you want to stop the class. Last 15 minutes, everyone now. For Devmini Herat. Then who else? That Nada, Sherwin Salash. Oh, that girl, Hasna, Hafna, whatever. Just put an answer. How many electromagnetic waves in the spectrum? There are others. No reply. There are infinite amounts of electromagnetic waves in the spectrum. That is important thing. Most of the people, they say there are 7 electromagnetic waves in the spectrum. That's wrong. There are 7 regions in the spectrum. Based on the frequencies and wavelengths of the electromagnetic waves, for our convenience to study about the electromagnetic waves, that infinite amount of electromagnetic waves categorized into 7 regions based on the frequency and wavelengths. So there are only 7 regions in the spectrum, but there are infinite amounts of electromagnetic waves. Then what are the 7 regions? Radio, micro, then what? IR, visible light. That's what we are talking. Now, in optics, we are dealing with visible light, ultraviolet, X and gamma. Those are regions. Specifically in optics, we are talking about electromagnetic waves in the visible light region. We consider that as light rays. Commonly we consider that as light rays, and we have studied until now. Okay. If I ask you specifically in the visible light region, in the electromagnetic spectrum, radio, micro, ultraviolet, visible light, infrared, X and gamma. In the visible light, this region, this spectrum, how many electromagnetic waves are there? How many electromagnetic waves in the visible light? How many electromagnetic waves in the visible light? Any idea? How many electromagnetic waves in the visible light? Again, there are infinity. Entire electromagnetic spectrum, there are infinite amounts of electromagnetic waves. When you take visible light region, there are infinite amounts of electromagnetic waves. Talking about each and every electromagnetic wave, they have their own frequency and wavelength. Frequency and wavelength of a electromagnetic wave is unique for that electromagnetic wave. The whole, like home address. Any home, any house in the world, they have their own home address. Very similar manner, there are infinite amount of electromagnetic waves in the spectrum. All the electromagnetic waves have their own frequency, unique frequency and unique wavelength. Two electromagnetic waves can't have same frequency or same wavelength. Any two waves, electromagnetic waves, can't have same frequency or same wavelength. It can't be. Every electromagnetic wave have their own frequencies. One example, this electromagnetic frequency is 300. This one 400, 451, 459.6, 459.77. That's important. Then you know that because of that, generally now, we define refractive index of light rays, refractive index of the medium when this light rays enters 1.5, 1.2, 1.4, something. But we considered common, all these light rays, we just considered into a one category and we discussed refractive index. But explain in detail, you understand, In that light ray, in visible light region, there are infinite amount of light rays. Infinite amount of light rays. Each light ray has their own frequency and own wavelength. Own frequency and own wavelength. When wavelength is different, understand when light ray, when that relevant light ray, let's say the light ray with a frequency of 1 hertz, when that light ray enters through a glass, through a medium, the way how it interacts with the molecules in the medium is different. Even in the visible light region, there are infinite amount of light rays. All those infinite amount of light rays have unique frequency, unique wavelength. Those infinite amount of light rays, when they move through a medium, the way they interact with the molecules are different. Therefore, understand each and every light wave has their own refractive index. Do you understand? Commonly, when you consider light rays, refractive index of light ray is 1.5. But specifically, when you highlight light ray with this frequency, light ray with this wavelength, it has its own refractive index when it passes through a medium. So therefore, refractive index commonly we define for light rays, but when we learn much specifically, every light ray in the spectrum has their own refractive index when they enter to the medium. Raise your hands up to now, everything is very clear. Raise your hands up to now, it is very clear. Now what happens? Now what happens? Now wavelength. Now every light ray in the spectrum, they have different wavelengths. Differently, they interact with the molecules in the medium. Therefore, what they do, each and every light ray deviates in the medium differently. Different wavelength means different speed. Commonly, we consider speed of light rays as 300 above 80 ms minus 1. But light rays, each light rays have different speeds in different mediums. Each light ray specific frequency. Then what's happening? When set of light rays enters to a prism, as those light rays interact with the medium is different. So therefore, what will happen? Each light ray, when it passes through the medium, they deviate different angles. When they deviate different angles, we see some kind of colors coming out from the prism. That's the idea. Okay. Up to now it is very clear. Raise your hands. Up to now it is very clear. If you understood, hands up. Understood up to now, hands up. Understood. Okay. Now write down. I will explain further. Okay. Okay. Now write down. Okay. Write down. As refractive index of light waves are different. As refractive index of light waves are different. I will explain, don't worry. As refractive index of light waves are different. In the glass prism, the refracted angle made by each light ray, the refracted angle made by each light ray is different at first surface. Therefore, it is observed as a separation of light rays. In the glass prism. Okay. Now listen, now I want to teach you further regarding that. But okay, now